Yeah. Right. This is 9. Isn't it? Yeah, this is 9. Okay.
So why don't you pass the lecture? This notes.
Because students think that because they have the notes then everything is okay. And it's not okay. They think I have the notes, everything's going to be great. But just because you have the notes, that's no good. You need to write the notes down so you can learn them and understand them.
Yeah, write the calculation.
And anyway, if you missed something, you have the video. Yeah. Okay. Projectiles. Write this down, please. Got it? Yeah? Okay. Right. So what on earth is a projectile? Yeah. So a projectile is something that travels. Now you don't need to write this definition down if you don't want to. This is only for English, okay? Vocabulary, not so much physics. So a projectile is anything that travels through space with only the force of gravity on it. So it usually travels along a parabolic path. So anyway, this is a projectile. Anything that you throw that moves in the air, like this, is a projectile. Okay? So, if I throw this at Amanda, this is a projectile, because it's moving in the air. And there's only one force on it when it moves. What's that force? Only force is the weight, the gravity. That's the only force.
So, if I jump down,
you are a projectile. Congratulations. Yeah. You got the idea? So this is a projectile. So this is a projectile. And once the bicycle left the ground, then the only force is gravity. The quad bike. Or no, it's a motorbike. Whatever. Okay. So this is a projectile. And you see that word there? Parabolic path? That's the name of the shape. You see the way it has this kind of curve? This curve is called parabolic path or parabola as the noun. So parabolic is the adjective, parabola is the noun. We'll use this word in math class again, so don't worry. Right. Why is he not a projectile? Seriously, why is he not a projectile?
Because he's using his force to fly.
Yes, he's using his force to fly. So he doesn't travel like this, he travels whatever way he wants. Okay, so this is not a projectile.
He can control himself.
Yeah, he can control himself. This is why he's not a projectile. Unlike if you jump out the window, you don't control yourself anymore.
Plane is not projectile.
Plane is not a projectile, helicopter, rocket, these are not projectiles.
Nobody can control them, so...
Yeah, so you can either scream or not scream when you're falling to the ground. This is the amount of control you have. Alright. So there's a few key ideas here. Now we need to make note of these points and we'll explain them. So the first one are the dimensions are independent. What you got? Check what? Yep.
The project.
Projectile.
In Chinese.
Oh, no. Try not to do this. Yeah, don't do this.
No, I don't like English.
You do.
No.
No, you do.
No.
Right, what do I mean by this? When I say the dimensions are independent, I mean that the horizontal and the vertical are independent. In other words, it makes sense. Think about this. It doesn't matter what the speed here is horizontally, it doesn't affect the vertical speed. Okay? So if this goes slow, it goes slow. If it goes fast, it goes fast. But it's not going to suddenly go up because now it's going fast. So the horizontal and the vertical, they're independent. One does not affect the other. Gravity is only on the vertical. Of course you know this. Gravity only goes vertically, not horizontally. There is no acceleration in the horizontal. So horizontally, there's no acceleration. It's zero. Yep. We can use vectors for projectiles. And we've also seen this already. When a projectile is at its maximum height, there's no vertical speed. And finally, remember, f is position, not distance. Okay. Yeah. Okay, you got it?
No.
No. Yep. Okay. Said it enough times. Don't think I need to drive that point home anymore. Right, so now let's see these ideas in practice. So I'll just draw what's happening here. A projectile is fired at an angle of 30 and a speed of 100. So what's happening here? So here is my projectile, and it's fired at a speed of 100 meters per second, and the angle here is 30 degrees, and the projectile will go like this, and then of course it will come back down and land here. So my first question is, what is the time, what is the range, and what is the height? So I would like to know for this question here, what's the time it takes to hit here? What's the range? The range means this distance here. This is called the range in English. And I also want to know what is the height. Is that everything? What is the time, what is the range, and what is the height? So you don't need to write the English down here. You can just draw the picture. So remember I said the dimensions are independent. That means the horizontal and the vertical are separate. So what I'll do here, now I hope everybody remembers how to do this, because it was like last week. I can break this into two parts. How big is this piece? How big, what's the formula for this piece here? 100 cos 30, and this one? 100 sine 30. So if you look in the x direction, the u is 100 cos 30, which is 15.43 meters per second. And if you look in the y direction, the u is 100 sine. Oh, sorry, no, it is not. I have my calculator in radian mode, like a fool. 100 cos 30. Sorry, it should have been 86.6, and then the other one is 100 sine, which is 50. Now there's always there's a way I like to think about these projectiles. So can you imagine here, look, here's the ball. And do you know those little lasers? You know, you shine a red dot. You know what I mean? The little laser? Yeah, it has a little red light, and you point it and it makes a little red dot on the wall. You know these? Yeah. So I want you to imagine that there are two of these on the ball. One that points down and one that points across. So if you look here, imagine the laser's going down, it makes a little dot here, doesn't it? And here there's a little dot, and here there's a little dot. So when I say x, it's like I'm looking at this dot here. This dot is has a U of 86.6. And then there's a laser here that makes a dot on the wall. Let's say there's a wall here. So what this happens vertically? Where's the dot at the start? At the beginning, where's this dot? Yeah, on the ground, isn't it? And then what happens to this dot? It goes up. And then what happens? After here. What's next? Does it keep going up? No, what happens? It goes down. And then at the end, where is it? On the ground. But the other dot is not on the ground, it's over here, over across here. So actually this is very useful because it means you know here the S should be 0. That at the end there is no height. The SY, if you want to think about it, is 0. But of course the S here is not 0, this is actually equal to the range. Okay, what's the A vertically? Vertically, what's the A? Minus 9.81. Now, if you want, if it helps you, you can put like UY, VY, SY, AY here, and UX, VX, SX. What's the AX? Y. I told you there's no acceleration horizontally, only vertically. Okay, and then yeah, we have enough information to get the time. So should I look at X or should I look at Y to get the time? No, not X, because we don't know enough information. We only know 1, 2. But in the Y, I know 1, 2, 3. So this can give me the time. So I'll use the formula.
So that's still the same.
Oh, it's the same. But I can't find it here because I don't know enough. But it is the same.
The same here.
Yeah. F equals UT plus a half AT squared. So now I have the time. It would work out, if I calculate it, I get 10.19 seconds. And we've seen how to solve this one earlier today. We know how to do this one. Okay.
And now it's the same.
And then, yes, then what you can do is you can put that here. Now we can find the range, because the range is equal to fx. Range. So now I want the x horizontally. So that's equal to u t plus a half a t squared. There's no acceleration horizontally. So I have my range is 883 meters.
Are there particular formulas to use?
No, it's all just the formulas we have been using. You just need to have the right information in the formulas.
What about the technical range?
It's 0, because at the end it comes back to Earth. So the last thing I want now is the height. So if I want the height, should I look at x or should I look at y? Yeah, look at the y now. Okay, what's the u? 50. What's the v? And I'm looking here. 0. What's the a? Minus 9.81. Do I have enough information to get x? I do. Because I have 3. So I can say v squared equals u squared plus 2af. So the height, which is the x here, is 127 meters. Okay, let's go to the next example. Yep, next example. Okay, so a girl throws a small stone at the side of an apartment block which is 25 meters away. I should fix that there. She throws the ball at a speed of 25 at an angle of 60. The ball leaves her hand at 1 meter. Okay, so I'll draw the picture so you don't need to write it all down. The building is 25 meters away and it's 2561. Okay. So this is the problem. This is 25 meters. This is the building. And the girl, here she is again. And this here is 1 meter high. And she throws it at a speed of, I think I said, what did I say? 25 also. 25 meters per second, and the angle here is 60 degrees. So the ball goes up and then hits the window here. To whoever she's trying to get in touch with. So I ask, what is the height, isn't it? What is the time and what is the height? Yeah, so my question is, how high is this? And then what's the time as well? Okay, so again, let's have a look here. We'll break it up into x and y. U. Okay, so how can I find the speed u in the x horizontally? What is it here? What's the formula for it?
25.
Yep. Go on. 25. No. I want this. What is it?
25
Come on, somebody. 25 cos 60. And then what's the u in the y?
25
It will be what? 25 sin 60. The v, we don't know. What's the a in the horizontal? What's the acceleration horizontally?
horizontally.
Yep,
No.
0. And what's the a vertically?
No.
We do? Minus 9.81. Okay. Now, what's the s horizontally? Yeah, and in this case we know, what is it? Yeah, sorry, what is it? 25. What's the s here? You don't know, it's what you want, it's the height, it's what you want. Do we know the t? No. So remember, this time, which one should we use to get the time? The horizontal or the vertical? Horizontal. Yeah, great. Why? Don't know? Okay. Oh, you know now?
The distance.
No?
Time is the same, sir. Time is the same in horizontal.
Yeah, but why do I use this one to calculate and not this one? Huh? What's wrong with him? You know? What? Yeah, you have 1, 2, 3 here.
Yeah.
How many do you have here?
1, 2.
Just 2. No good. This one, you can use it. This is why. Okay, what formula? Let's see, we'll use S equals U T plus a half A T squared. So what's the T? What's the T? Yeah, what is it here? Come on, you can do this in your head. What's the T?
2.
Thank you. 2 seconds. Now, can I use the same T here?
Yes.
I can, so I bring it over here, and this is also 2. Now we have 3 pieces of information. We can calculate this. Yeah, so again, S equals U T plus a half A T squared. So now the height, which is the S, will be um, 21.65 times 2 minus 9.81 times 2. So I got a height of 23.7 meters. Now, what I want you to see is that I'm still using the same equations. We just need to think carefully about how to use them. Let's have a look at another example.
Okay.
Tom and Louise drive their car off the side of the cliff at the end of the movie. The cliff was 400 meters high and the car was traveling at 36 meters per second. Right. So I'll just draw it for you. This is what you have. You have a cliff. Then we have the ocean. Then we have our car.
What's that?
36 meters per second, I think I said, wasn't it? Yeah. And this is 400 meters high. So what happens here? That's right, it goes like this. No, it doesn't, of course not. Just wanted to see if you're still awake. Goes like this, doesn't it?
Yes.
And what I ask you for is, I would like the time, the range, the velocity and the speed. So I want to know the time, I want to know the range, which is this, and I also want to know the speed and the velocity when it crashes here. Yeah, final velocity. Huh? That's the speed at the beginning.
Okay, you.
Yeah. Let's look at X, let's look at Y. U, V, A. Can I squish it down a bit? Yeah, we can still say U, V, A, T, S. U, V, A, T, S. Okay. So Fahad, what is the U horizontally here? What is it? If you don't know, that's okay. What about you, Amanda? What is the U horizontally? 36. And Grace, what is the U vertically? No. Good try. Not this. Soki, do you know? What's the U vertically? 0, yeah. Why is it 0? Why is it? Yeah, go ahead. Yeah. Why is it 0? Look, the car, at the beginning, the car is driving on the road, isn't it?
Yeah.
So, does it have a vertical movement?
Yeah.
No, but not at the beginning. It only has horizontal. So in fact the V is 0. It's not moving vertically. It's only moving horizontally with 36 at the start. Now at the end, it definitely is moving vertically. Not at the start. Okay, so the V, we don't know. What's, Yenny, what's the A here horizontally? Do you know it?
0.
You know, yeah, 0. And what is it here? Minus 9.81. Do we know the T's? No. But we know 400. Which is the 400? The X or the Y?
Y.
The Y. Okay. So which one do we need to use, Amanda?
Y.
Thank you, you got it, yeah. So we use the Y. And so, let's calculate the time. Again, X equals UT plus a half AT squared so I got T is equal to from here 9.03 seconds, which means that this is also 9.03. And now that I have this, I can get the S, which I want. The range, which is the S here, that's equal to U T plus a half AT squared. So this is 325 meters. So now we have this one also. 325 meters. Lastly, I want the speed and velocity. So lastly, I want to find this one and I want to find this one. So we'll just use what formula? We'll just use V equals U plus AT. So that will be 0 minus 9.81 times 9.03. So that is minus 88.6 meters per second. And here, the V is U plus AT. But what's the A? Here, what's the A? What's the A here?
0.
0. So what's the V? It's just 36. So, look, velocity, is that a scalar or a vector? Vector. So, the answer is Vx equals 36 meters per second and Vy is equal to minus 88.6 meters per second. And if you want to draw it, it's like this. This is 36 and this is 88.6.
So if you start hitting x-axis, V always equal mu, right?
Yes, always. Yeah. Okay, that's the velocity, but that's not what the speed is. Who remembers the relationship between speed and velocity? What's the relationship? Yeah, speed is for distance, yeah, but I mean, how can we, if we know the velocity, we can know the speed. Does anyone remember how to get the speed from the velocity? No, it's already resolved.
What's the time?
No one remembers, it's okay. The speed is the magnitude of velocity. So the speed is whatever the magnitude here is of these two. Well, do you remember the formula for magnitude? What is it? It's our good friend Pythagoras. You know our buddy Pythagoras? You do. What's it? Gogo-D or something? Google-D? What's the Chinese name? You know him. That's the one. Yeah. He's our friend. Square root 36 plus 86 there. So I get speed is equal to 95.6 meters per second. That's the speed. Now I want to draw and make it very clear the difference between the two answers here. So I'm going to go down. Here's the car hitting the water. What I'm saying is the velocity horizontally is 36 when it hits the water, and vertically it is 88.6. But if you put them together, the car hits the water at 95.6. Okay, so this is the horizontal and this is the vertical and this is the total. If you think about it like that. Hang in there. Have practice next time. Do you understand what I mean by the difference between velocity and speed here?
Yes.
Yeah.
So if you were in the car, which one do you really care about, velocity or speed? Speed. That's how fast you hit the water. You don't really care about your horizontal and your vertical velocities. You only really care about the total speed when you hit the water. Yeah? And you also care about hitting the water, yeah. Well, that's not really completely true. If you hit the water, which would you prefer? A big horizontal and a small vertical speed? or a big vertical and a small horizontal? Which is better for you?
Big horizontal.
Big horizontal is a little better because then if the car hits the water with a big horizontal, it hits it more at an angle. Whereas if you had a big vertical, it's more like this, which is worse. So in both situations, the speed could still be 95, but realistically, it's better if you hit the water not so vertical. But either way, you're probably dead. Hang on.
Oh no.
I think what we'll do is I'll give you the questions. Yeah, I've still got 2 more examples. So hang on, let me think. Wait. Take your stuff out. Take it out. Everything out.
So we're hungry.
So am I, but I had breakfast. Did you have breakfast?
No.
So this is your mistake.
Yeah.
What do I want to do? I have more examples here, but I think I've given you enough examples maybe to try the questions. When is our next class? Is it Friday? Today is Tuesday, isn't it? Yeah? We have physics tomorrow. No, Friday. Yeah.
Friday. Excuse me, those questions you gave us, where are we supposed to get them from?
Hang on, let me think. I'm thinking about what I want to give you.
No, the ones you gave us.
Give me a minute, please. Alright, I'll tell you what we'll do actually, because the previous lesson... No, don't. This lesson was quite big, and the last lesson was quite big, and I think what we'll do is, for your homework for this one, we can, I know what we'll do. We'll make the 2 examples I didn't do, the homework questions. So you can do those 2 for homework. And then, on Friday actually, instead of doing the exam questions I gave you, I still want you to try them though, but instead of doing those questions in class, on Friday we'll do the exercise. So listen carefully for your homework, okay? So the video is recorded, so you can look it on YouTube or you can take a picture. So you have 2 questions for homework. So this is the first one for homework for Friday. Actually, no. Yeah, it's for Friday, but I'll check that you did it in maths class before Friday. Okay? Because there's only 2. And then this is the second one. In maths class.
That's not fair.
Oh, it is.
And the exercise on Friday.
No, listen. You listen and you'll understand. So, those 2 questions here, they are for tomorrow. I'll check them in math class. Tomorrow. Just listen. Just listen. So these 2 questions are for homework tomorrow. The reason for that is I want to make sure you can do them. Because then these ones here are for Friday.
You didn't give us a question.
Also take notes for this?
Okay. I don't want anybody to say anything for the next 2 minutes. So you can just listen. Alright? And I'll give you everything you need to know. No, don't even take a picture. Okay? This is question 1 of homework for tonight. This is question 2 for homework for tonight. This lesson is recorded. After this lesson, I am uploading this video to YouTube. If you didn't take the picture, you can just pause the video and write the question down. This homework is due for tomorrow. Secondly, these revision questions, I will upload them to Moodle. And these are for Friday. In the second hour on Friday, I will spend most of the time probably doing these 5 questions. And also the 2 other questions you had from homework. So I'll do these 7 questions in the tutorial on Friday, and this will take up most of the time. If there is time left, I will check and do any problems from the exam questions. But maybe we won't worry about exam questions just yet. Maybe we'll worry about starting the exam questions in a few weeks, because I feel like you probably have enough here in homework. Would you agree with that?
Yes.
So how about we leave the exam questions for maybe after the mid-semester, and we'll just focus on our problems during the week. Okay? So, 2 questions for homework tonight. I'll check them tomorrow. 5 questions for homework on Friday. I'll do all 7 questions in the tutorial. So you have an extra big homework for this lesson, and it's difficult. If you have problems, please see me in the office. I can give you some help. Okay. Now, do you have anything to say?
Thanks.
Oh, good. Right. I'll see you for maths next then.